The second example that's given in the notes details a condition that results in abnormally low platelet counts that often occurs during NEC. Forgive me for skipping over most of those words, but I can almost promise you that I would have butchered their pronunciation. So we're going to stick with the acronyms. The goal of this study was to compare the mean platelet count across 4 different categorizations of NEC status. And you can see in the setup of the problem what those 4 groups are. In the example given in the notes, we didn't go through and actually check the assumptions for this data, and in this video we will go through those assumptions. The first thing that we would like to notice is this data is structured differently than the data in the previous example. In the example that dealt with the force to break the femur, we had 1 column that held our response. In this case, our response is the log 10 platelet count, but now we have 4 columns of those values, 1 column for each of our 4 groups that we're interested in. This data structure is probably more familiar to you than the previous structure was. So if we start with the assumption of normality, we would like to create histograms for these 4 groups. In this case, I don't have to worry about a group by variable because now I can individually select groups 0 through 3. If you would like this graph to come or to appear in the same structure that the previous one did, we can click Next through to the end, and in this case, since we're comparing 4 groups, I would like to have 4 columns to this page of graphs. In the resulting output, we have 4 separate histograms, the first for group 0, the last for group 3. And you'll notice that group 0 and group 1 appear to be somewhat negatively skewed. Group 2 and group 3, while not perfectly symmetric, do appear to be more bell-shaped. So as with the last example, we might want to proceed with caution in terms of the normality assumption. Again, we can also calculate summary statistics for this data to assess the variability. And this is similar to the approach that you took before. Now, though, we want to select all 4 columns that contain our data. And in the summary statistics that appear, you'll notice that if we start to compare standard deviations, twice the smallest standard deviation of 0.37 is much larger than our largest standard deviation of 0.46. Therefore, we could assume that the underlying variability for these 4 classifications of NEC status concerning their platelet count is approximately equal. So now we're to the point where we could go through and do an analysis of variance on this data to assess whether there's any difference in the mean platelet count. So if we come to our ANOVA menu, again we're going to consider a one-way ANOVA because we have 1 factor that we're interested in, and that factor is our classification status. The analysis that we choose to do in this case is going to be slightly different though, because now we're not going to compare values in a single column. We want to compare our 4 columns of data, group 0 through group 3. So I'm going to select each one of these columns. I'm also going to select the Tukey HST. Again, that will give us multiple comparisons. And then we can select Calculate. Again, the output that appears is exactly similar to the output that we saw in the previous example. You'll notice that the top half gives us our analysis of variance results. Again, the component that we're interested in is the F statistic and p-value. If you look at the bottom of this output, you'll notice that we now have more confidence intervals. Now, the reason we have more intervals for this particular example is because our factor of NEC classification had more levels. Instead of only comparing 3 groups, we were comparing 4 in this case. And if we looked at every possible pair of groupings, that left us with 6 possible pairs. Now, on this example, if you look at your confidence intervals, you'll notice that the majority of them have a negative lower limit and a positive upper limit. So for all of those groups, we can't come to the decision that those are statistically different. There's only one case where we have an upper and lower limit with the same sign, and that occurs when we compared group 3 to group 0. So in this case, we notice that group 3 minus group 0 results in a negative lower limit and a negative upper limit. So in that case, we're able to conclude that group 0 has a greater mean platelet count than group 3 had. No other significant differences were found. Now, in the practice problems that are posted for this chapter material, you'll see data that's in both formats, where we have one column containing our response, one column containing our factor. And you'll also see the case like the platelet count, where we have individual columns for each level of our factor containing their response. Be careful how you analyze that data. Within the ANOVA menu, you have to select the appropriate format. Please let me know if you have any questions on these practice problems or on the procedure analysis of variance.